what we're going to be going over here is a linear programming example where we're going to be determining the production plan or the budget for our production here based on the sales budget and stocking requirements. Okay, so for example, let's go up here and start with it. So for 20x1, we're trying to determine the production plan here, and it's going to be based on the sales requirements and our stocking requirements. So for 20x1, we've got really two products. We're going to be looking at product A here and product B. So first for our sales on a unit basis here we're budgeting for 20x1, and I've got them shown here by quarter 1 through quarter 4 here. And then we're going to have these units that we're going to have to be selling here for product A and product B that we've budgeted. Okay, so that's for our sales requirements. Now for our stocking requirements here. So this is the stock that we're going to have to maintain. So as of the first, based on 1/1, or when we start here in January, at the beginning of the year here, as of a percent of our first quarter sales, we're looking at 20% here for product A, which would be what, 20% of 2,000 units here that we have. So that's going to have a stock that we require on hand as of the beginning of the year here would be 400 units. And for B here, we're requiring 100% of the first quarter sales, and we have quarter sales here of 4,000 units for product B. So that gives us a stocking requirement that we need here as of the first of the year here before we start any production on 1/1x1, 4,000 units in stock here for product B. And then for the next quarters, we'll go through it. We're going to need 50% of the next quarter sales that we're going to have on hand for the end of each of the quarters here. And then at the end of the year here, as of 12/31x1, we're going to need 4,400 units here of product A and 2,000 units here of product B that we have at the end of the year that we have. And the only reason I put in these numbers here is to see how you would include those in your linear programming. And then the other thing we're going to have is our selling prices on a per unit basis here for product A is $60. And we have a gross profit ratio on product A of 20%. So our unit cost that we're going to be dealing with here would be 80% of $60 or $48. So that's the key figure that we have to deal with. And then for product B, well, we got a 25% gross profit ratio with a selling price of $80. So 75% of the $80 will be our unit cost, or $60 here, the unit cost. Okay, so those are the statistics that we have to work with here for product A and product B. All right, so now let's go and let's set up our linear program. Okay, so this is going to be our production plan here that we have budgeted for 20x1. And you lay it out this way here by product. We're going to have our product A here and product B here. And then just show it on a quarterly basis here. Quarter 1, 2, 3, and 4 for product A. Same for product B. Quarter 1, 2, 3, and 4. Now, the budgeted sales. This is the next deal we have to deal with. So maybe we could go and look at that. So I'm just showing these budgeted sales, and let's go back to it and look at it here. So just to understand what's going on, those are the budgeted sales we have coming off our sales budget here for product A and product B, just to see how they fit into our production plan here. So those are our sales requirements by quarter here for each of our products here. And then our stocking requirements reset. In this case, we're going to remember we had that 50% stocking requirement that we have to have at the end of the quarter. We have to maintain a stock requirement that we have on hand at the end of the quarter. And we're saying it has to be 50% of the next quarter's sales here. And we're just throwing that in here so you understand how you can intertwine these stocking requirements into linear programming. You have to come up with some solid numbers here when you're putting in those stock requirements. Okay, so and just going through here for product A, let's just say here as of the end of the first quarter here, we're going to need 50% of the next quarter sales. And if our next quarter sales, we're budgeting at 4,720, so 50% is 2,360, and so on here. For the next quarter here, quarter 2, we're going to need 50% of the next quarter sales, which is quarter 3 here, 4,320, 50% of it is 2,160 units, and so forth. So you do that for each of your quarters here. And then in the case here of that last quarter, we're giving a specific number here of 4,400. And same for product B here, just say 50% of your next quarter sales. And then that last quarter here the stock requirements for the end of the quarter here was set at 2,000 here. Okay, so we have our budgeted sales that we have here and the stock that we have required here at the end of the quarter. Okay, so now setting up our linear programming. So the objective function here is to minimize our production cost here. So what you're going to do here, in this case, remember we had that unit cost here for, and I got it lined up here, product A and product B here. So what we have to do is we have to, the units of product A that have to be produced by quarter here. So we're going to have that production cost, that unit production cost here for product A, we had at $48 here, times the quantity here of units that we produce for each quarter. And you got to have to index it in your program somehow, and I've got everything indexed here in sort of a matrix form where X11 stands for quarter 1 here for product A, X12 quarter 2, X13 quarter 3, and so forth. X14 would be quarter 4. And then moving over to product B, we add into our objective, or minimizing our objective function, also would include our product B production here, or the unit cost here, $60 times the total number of units that we're going to produce here. And I've got them, this is what we're trying to solve for, the number of units that we produce by quarter. And in this case, I'm going X21, I had X11 before here, plus X22, plus X23, plus X24. So you see, you have to index it into your linear program in some fashion, or identify there's the number of units that you're going to have to produce by product A and product B. So we're really dealing with 4 quarters here for both our product A units and product B units. Okay, so that's our objective function. We want to minimize the production cost in this case. So that's the idea here when we're coming up with our production plan. We want to have a minimum production cost. Okay, so now for our product constraints here for product A here. And we'll go through A here and then we can skip over and index through product B constraints. But they work in this fashion. So what you're going to do here, you start out with your units that you're going to produce here, and that would be X11. That's the number of units here in the first quarter, plus you add in whatever you have to have here at the beginning of the year, your stock requirements. In this case, we calculated that for product A to be 400 units. And then you're going to subtract from it the stocking. S11 here stands for the stock that you got to have at the end of the period here. So let's understand those S11s here so you don't get confused with the sales here. So let's go down and look at that. So S11, that's quarter 1, S12, S13, S14. That represents the stock of product A at the end of each quarter. Again, I've got it sort of indexed here, and you have to identify them by quarter. Okay, so that's that. Okay, so you've got this first quarter's requirements here, and we talked about the beginning of the period stock here of, as of 1/1, we need 400 units, and then we're going to subtract out whatever stock, and this we're also going to be determining in our linear program here. We have to determine the stocking requirements at the end of each quarter. So you'd subtract from at the end of the first quarter here, S11, and that's going to equal 2,000 here. So where do we get the 2,000? Those are the budgeted sales for the first quarter. Let's just go up and look at that here. Those are the budgeted sales here for the first quarter here. Okay. And one thing I want to point out here, I've set this linear programming up here so you understand where you on this side, and remember it's an equal to here, not less than or greater than or so forth. It has to be an equal to in this case. But I've set it up here where you look at what you have to understand what your beginning stock requirements are, and then you'd subtract it from your entering stock that you're going to calculate for the quarter here. But when I do the linear programming, if you leave this 400 on this side of the equation and 2,000 here, which is your sales requirement, you're going to come up with a different solution than if you move this 400 over to this side of this equation, which you'd be subtracting 400 from 2,000, and essentially you got 0 here, and you come up with 1,600 here. And that's the way I've done my program. At least with my linear program here with MapleSoft, that's what I have done here. So otherwise, if you just leave it as is, you're going to come up with a different solution. Okay, so that's for our constraints here for the sales of the first quarter. And then the next quarter, let's go through that pattern. Okay, the next quarter, X12, units that we have to produce here in X12 are the second quarter, plus whatever quantity S11, the end of the stocking require, or the stock that we maintained here at the end of the first quarter, you add that to it, and then you subtract out whatever stock you're going to have here end of the second quarter, S12. So you can see the pattern we're following. And then again, that has to be equal to our sales for the second quarter, that 4,720. So if we go back and look at that here, there's your 4,720 up here. Budgeted sales for the second quarter. Okay, so you see that pattern. Okay, and then for the third quarter here, number of units X13, you add to it the stock that you need at the end of the second quarter, X12, and then you subtract whatever you stock you're going to have to determine here for the end of the third quarter. You see the pattern here. Subtracting S12 here for the second quarter becomes a plus here when you're determining your quantity that you have to produce here for the third quarter. And then you just subtract out whatever stock we're going to require here at the end of the third quarter. Again, that equals to the 4,320, the sales for the third quarter. So we can go up and look at that. There it is, your sales required for the third quarter. Okay, and then we're going to end up here in our sales for the last figure here for the fourth quarter. Just understand how this works in. So our requirements here, X14, the units that we have to produce here for the fourth quarter, plus you add in the stock that we had at the end of the quarter. And this is the case here, again, where you're going to have at 12/31, we determined that we're going to need 4,400 units on hand. That was a given number we have on hand. So you're going to subtract that from your quantity you're producing here plus your stock that you had here at the end of the third quarter. Subtract that, and that's going to give you your 4,960. That's the sales that we require for the fourth quarter. So we can go up and look at that again here. There's your sales here for the fourth quarter, the budgeted sales, 4,960. Okay, so that's it. And again, with this minus 4,400 on this side of the equation, and it doesn't work, you're going to get a different solution if you leave it there. In my case, again, equal to, I just move that over to this side of the equation, so that brings it up to 9,360 here. Okay, and then the other thing you've got to have here, that stocking requirement, that next 50% of the next quarter, this is what you're going to have to stock at the end of the first quarter, X11, has to be greater than 2,360, and we can go look at those here. X12 is greater than 2,160 units, and S13 here, stock at the end of the third quarter, is greater than 2,480 units. So let's go up and look at that here. Okay, back to our stocking requirements for the end of the quarter. Remember, we calculated that based on 50% of the next quarter's sales. So those are hard numbers that we have to put into our program here. In this case, it has to be greater than or equal to here. Not equal to, but greater than or equal to, because that's a minimum stock that is requirement here. And again, just remember this is S11 and so forth. That was the stock A here at the end of the quarter. Now you assume, I have to assume no non-negative. You might see that you're going to have to assume or put in your program has to be, all these variables have to be greater than, they can't be negative. They have to be greater. If you put no non-negative, or say they have to be greater than or equal to 0, or greater than 0 here, equal to 0, you're going to get a different result here, and it won't be as good here. So for leveling production, I put in no I'm not assuming any non-negative here, or greater than or equal to for my variables. Okay, so that's for product A. In product B, the same thing. We'll go through it. Just skip through it real quick here. For product B, again, here X21 here. Those were the sales here for the first period, plus the stocking requirements. In this case, we required 4,000 units here that we had to have on hand, or 100% of the first, or the sale. We set up 100% of the next quarter sales, or for that period, or that quarter sales here. So again, just the number we put in here, that's what you have as of the beginning of the year. So just remember, you have to have some stock on hand at the beginning of the year here, and that's what that is. Then you subtract out your stock here at the end of the year, and then that equals, again, go back to it, and we'll skip through that fast here. Sales for the first quarter, that was those 4,000 units here. And then X22, again, same pattern as we use for product A here. And remember, X22 here represents the product B that we're producing here, plus the end of the second quarter's, first quarter here, get the first quarter's stocking requirements, add to that, and then subtract out the end of second quarter's stocking requirements, and that equals your sales here for the second quarter. We won't go up and look at that. That was 2,000 units. And then same thing, X23 at the end of the units that we're producing here, product B for the third quarter. Again, just add in the last of your last quarter, second quarter here, the stocking units, you add that to it, and then subtract out your stock units here that you're determining here for the third quarter here. And that has to equal to 2,500 units here, or that's our sales for the third quarter. And then the same thing here for the end of the quarter. X, the fourth quarter units you're producing, you add back your last quarter's stock here, and then you subtract out. Remember, we were given a hard number here. 1231 was 2,000 units here. Again, and you see we'd subtract that here, and that has to equal the sales of the fourth quarter, 1,500 units. But again, I'm moving this 2,000 over to this side of the equation to get up to 3,500. If I don't, then my program is going to give me a different solution than I'm looking for here. And then again, 50, and then we have that greater than or equal to for our stock for each of the next quarters here, X21, 22, and 23. And those are the those at 50% of the stock that we have here. Maybe we better go look at that. That was that 50% of a next quarter sales here. Those units by quarter. 1,000 for the first, 1,250 for the second, 750 for the third quarter. So if we go back there. And then again, the last thing here, just remember the S. Remember for product A at S, our stocking requirement S11. Well, remember with stock B here, you have to keep some type of indexing in your linear program. In this case, I'm using S21, S22, and S23 and so forth here. Again, I'm assuming no non-negative here. If you can't assume it's equal to non-negative, you're going to get a different solution. Okay, so that's pretty much how we set up our objective function and our constraints here for a sales budget, a production budget here to minimize our cost of our production here, and based on our sales and also our stocking requirements. So next we'll go and we'll just quickly analyze the solution that we came up with. Okay, now just to go over our results here. So this was our objective function here, and then we went over our product A constraints here and product B constraints over here for units that we have to sell here and stocking requirements and so forth. Okay, so now going down and looking at our results here. So really what you want to do here when you're, whatever results you're coming up with, you really want to level your production requirements so they're rather level over the period here. So when you do your linear programming, you can use it here as a device here to determine really the minimum cost that we're looking for the production of these units here. But you want to look at make sure you get your production requirements that really fit into your plant operation that you'll be looking at. Okay, so if we look at the case here where we looked at the product A and product B that would be included here for when we looked at them as a total unit here, we'd had that minimum cost. Well, you're giving some minimum cost. In this case, it was $1,440,000 or something like that. And then you were given for product A, you would be giving your end of period stock that you'd be having here for each of those periods, S1 here through, in this case, third quarter S3 here. And then along with that, this is the key here, you'd be giving in the number of units that you'd have to produce here for each quarter for your product A here, X end of the first quarter here through the end of the fourth quarter here. Okay, so those are the results you'd have here. And then for product B, you'd be giving the same thing here. You'd been giving the end of period stock requirements for, in this case, quarter 1 through quarter 3. And then your production requirements for a number of units that you have to produce here. For B, you have the beginning, first quarter results here and your through your fourth quarter results here. Okay, so those are what you'd be looking at here. All right, and you can see the key here when you set up your variables, you want to set them up and try to index them as some matrix form here so they're easy to understand rather than just throwing in some odd number of variables like A, B, C, D, E, and F and so forth. Index them in a way that you can understand exactly what quantity you're looking at for what quarter. Okay, and then if we just looked at product A separately here, just say minimize the cost here of producing product A separate from product B, again, you're going to come up with a minimum cost here, $960,000, and then you're going to have your quantities here for the end of the period for your stocking requirements, and then your unit quantities here that you have to produce for each of those 4 periods as well here. But if we went back and just looked at them and relative to what we did when we included them, you're going to see included both product A and product B in one function here for one linear program. So if you look at it, product A separately, let's just go and look at what we'd have here. For X11, we had 3,960 units here when we for product A when it was included, versus 5,484 units here when it's done separately, and so forth. Here you're going to see you have a difference here. Period 2 or quarter 2, 4,520 units versus 2,996 units. Okay, so just keep that in mind here. And then if you looked at product B separately again here, and what I'm just saying, you take that cost function here that you have, and you're just minimizing the cost function separately here for both when we looked at product A and product B here. And then the minimum cost here will come up with 480,000. The key that we want to look here when we looked at them separately, if we looked when we did our minimum cost here for product A and product B together, we come up with 1,440,000. But then if we're looking at them separately, you're going to have the minimum cost here at 960,000 plus 480,000 here for B, 960 for A. They really total up to the same minimum cost here when you include them together. But you're going to have different quantity requirements here that you have for your stocking at the end of the period here, and what you have to produce here during the period here. So for, let's looking here at product B here, what we had for the first quarter, 2,190 units versus, go up here, product B only 1,385 units. And then looking at the second quarter here, 2,361 units here, we're coming up with 10,000 or 1,060 units here. Okay, so you can see quite a difference here in variation depending on how you it's really if you're looking at it separately or as a total here. And then the other thing, just remember that it's easy enough to use a linear programming here just to get an idea of what your minimum production costs might be and so forth by just looking at different stocking requirements and so forth here. You know, stock that you have to have based on sales requirements and different costs and so forth. But just remember, whatever results you want to come up with here, you have to carefully look at what you're doing, and you really kind of want to you want to come up with sort of a level production requirements. You don't want to go, you know, 10,000 X first quarter here, X11 produce 10,000 units here, and then maybe X13 or 0 units and so forth. You want to get something rather level so you can keep your production operation a level within the factory that you're looking at here, or your operation. Okay, so that'll pretty much summarize our discussion here on how you could set up a linear program here to determine your production plan based on sales requirements and stocking requirements.